All right, so we're going to start looking at the laws of logarithms. We're going to see that they are directly related to, connected to the laws of exponents. Remember, when you're multiplying powers with the same base, you add the exponents and you keep the base the same. When you divide powers with the same base, you subtract the exponents and you keep the base the same. The laws of logarithms are going to follow along those same principles. So they can be used when trying to simplify expressions involving multiple logarithms. They will also be beneficial when solving logarithmic equations. So this first question, the warm-up number 1, says to evaluate the following. The first one is log base 2 of 4 plus log base 2 of 8. What does log base 2 of 4 mean, Danny? What is log base? That's right. It means 2 to what power equals 4. And the value, that would be 2. 2 squared equals 4. And log base 2 of 8 means 2 to what power equals 8? The answer is 3. 2 plus 3 is 5. That's the value of log base 2 of 4 plus log base 2 of 8. Then it says to evaluate log base 2 of 4 times 8. Now 4 times 8 is 32. So this is asking 2 to what power is 32, which the answer is 5. And if you're not sure, you can always use it on your calculator. So either you use the log function on the calculator if you have one, log base 2 of 32, or you can also use the change of base identity, log 32, close the bracket, divided by log 2. Same answer. So what do we notice? Well, we notice that when you do log base 2 of 4 plus log base 2 of 8, it gives you the same answer as log base 2 of 32. That's what we notice. Then we are asked to evaluate log base 2 of 16. Take away log base 2 of 8. Log base 2 of 16 is asking 2 to what power is 16? That is 4. Log base 2 of 8 is asking 2 to what power is 8? That is 3. And 4 minus 3 equals 1. Then it says, what about log base 2 of 16 divided by 8? Well, that'll be log base 2 of 2. 16 divided by 8 is 2. And log base 2 of 2 is asking 2 to what power is 2? The answer is 1. Using the change of base, you can always also go log 2 over log 2. You're dividing something by itself. You get 1. So what do we notice? We notice that log base 2 of 16, take away log base 2 of 8, gives us the same answer as log base 2 of 16 divided by 8. I said at the start that the laws of logarithms are tied to the exponent laws. When you divide powers with the same base, you subtract the exponents and keep the base the same. When you multiply powers with the same base, you add the exponents and keep the base the same. Log base 2 of 4 times 8 is the same as log base 2 of 4 plus log base 2 of 8. Log base 2 of 16 divided by 8 is the same as log base 2 of 16 minus log base 2 of 8. So these are the product and the quotient laws of logarithms. Log base a of m times n is the same as log base a of m plus log base a of n. Because the m and n are multiplied together, it's tied to the laws of exponents. When you're multiplying powers with the same base, you add the exponents. When you multiply logs with the same base, you add the logs. And then the quotient law says log base a of m divided by n is log base a of m minus log base a of n. When you divide powers with the same base, you subtract the exponents. When you divide logs with the same base, you subtract the logs and keep the base the same. No different than dealing with exponents. Right? And I believe, let's just check real quick. For the formula sheet, but I'm pretty sure those laws of logarithms are on the formula sheet. So don't have to memorize them, just know how to use them. So yeah, there they are on the left side here. These are the first two laws that we were just talking about. And then we're going to look at a third law, an exponent law of logarithms, or power law. And then this last piece here, that's just the change of base identity. That's all that is. Normally, if you're going to do log base b of c, it's log c over log b. And normally that's how we write it, with a common log, so that we can evaluate it in our calculator. We talked about the fact that in reality, the base can be anything as long as they're the same. These both have a base of a here. Okay, so couple uses of these laws of logs. One of them is to help us simplify expressions involving logarithms. As long as the bases are the same, we can use the appropriate law. This first one, log base 2 of 96 minus log base 2 of 3, because you're subtracting logs, that's the quotient law. This would be the same thing as log base 2 of 96 divided by 3. And 96 divided by 3 is 32. So that becomes log base 2 of 32, which is 5. That's asking 2 to what power is 32. But you can do it on your calculator if you're not sure. So also note that the first two terms in the original expression, those answers would both be irrational, because log base 2 of 96 is asking 2 to what power equals 96. Well, that's going to be an irrational number. Same thing with the second part. Log base 2 of 3, 2 to what power is 3? That's going to be an irrational number. But by using the laws of logs first to simplify it, then we get a nice answer. Okay? Now you get the same answer if we put the original expression in our calculator. Log base 2 of 96 minus log base 2 of 3. So you get the same answer, but the question says express as a single logarithm, then evaluate. So that's what we did. Now question B, you've got the difference and then the sum of logs with the same base of 3. What I would probably do with this one is I would just rearrange those terms to put the plus part first. So after the log base 3 of 27, I'll put the log base 3 of 6, and then the minus log base 3 of 2. And so you can combine these laws all in one step. You're adding the first two logs together, so that's the product law, 27 times 6. But then you're subtracting log base 3 of 2, which uses the quotient law. So we would divide by 2. You can do it all in one step, combining all three terms into one expression. All right? So, I mean, you can go the 2 into the 6 to get 3, and then 3 times 27 is 81. This will become log base 3 of 81, which is 4. That's asking 3 to what power is 81. And again, if you're not sure, then use the calculator. Either the log function log base 3 of 81, or use the change of base identity, log of 81 divided by log of 3. Doesn't matter, you get the same answer. Okay. So question C, you're adding and subtracting logs with the same base of 6, so we can combine them all together in one step. Log base 6 of 9 plus log base 6 of 8 will be log base 6 of 9 times 8, and because you're subtracting log base 6 of 2, then we would divide the 2. So 2 goes into the 8 4 times 9 is 36. So this will be log base 6 of 36. So that's the first part of the question. We've written it as a single log. And log base 6 of 36 is asking 6 to what power is 36? The answer is 2. D is a little different because you'll note that there are 2 subtractions, and that means you're using the quotient law twice. But in math, we never divide by something and then divide by something else in the same expression. So here's what I'm going to do. I'm going to group together the positive logs and the negative logs. And then I'm going to group those last 2 together by putting them in brackets. With the minus sign in front, introducing brackets, that changes all the signs inside the bracket. So it looks like that. Because remember, it says write it as an expression with a single logarithm first, and then we can evaluate. If you remove the brackets, you get what was on the previous line. So what we've done is correct, but what we've done then is we can combine the first 2 terms together, and now we can combine the last 2 terms together as well using product law. So it'll be the log base 2 of 2 times 3, which is 6. Let me write this. Minus log base 2 of 6 times 8, which is 48. And now we are subtracting logs with the same base. We can use the quotient law to combine them. That'll be log base 2 of 6 divided by 48, or log base 2 of 1 over 8 if we reduce. So this is asking 2 to what power equals 1/8, which is negative 3. 2 to the negative 3 is 1 over 2 cubed, or 1 over 8. But you can get that on the calculator. Log base 2 of 1 over 8. Negative 2. Now remember, when we evaluated these before we learned about what a log means, well, not before what a log means, but before we introduced our calculator, if you wanted to evaluate log base 2 of 1/8 without grabbing the calculator, if you didn't have one at your disposal, let it equal x. Then turn it into exponential by starting with the base and cycling through. So 2 to the x equals 1 over 8. Or 2 to the x equals 1 over 2 cubed, because 8 is 2 cubed. Or 2 to the x equals 2 to the negative 3. Bases are equal, so the exponents are equal. Right? So that's how we started with evaluating logarithms. And then we learned about the calculator and that sort of thing. So as I said, there's a third law, the power law. It says show that 2 log x is equal to log of x squared. So we want to show that 2 log of x is equal to the log of x squared. Two log x could be rewritten as log x plus another log x. If you have something and you add another one, now you have 2 of them. And we can simplify this by applying the product law of logs. When you add logs together with the same base, you can combine them using the product law. It'll be the log of x times x, or the log of x squared. So we've just shown that 2 log x is equal to log x squared. And these laws, this one, the 2 previous ones, they go either way. Okay, you can go from the sum of 2 logs being the log of the first times the second, or you can start with log of a single number and you can break it up into the product of 2 numbers and write it as the sum of 2 logs. This is no different. This shows the power law of logarithms that log base a of m to the n is equal to n times log base a of m. Whenever you have the log of a power, the exponent can come in front and be a coefficient. That's what the power law says. Okay? And if we look back at the last one that we did, if you wrote this log base 2 of 1/8 as log base 2 of 2 to the negative 3, the negative 3 come in front, it'd be negative 3 log base 2 of 2. Log base 2 of 2 is 1. Negative 3 times 1 is your negative 3. So this one could have been done using that power law. Had we known about it, we just have to write 1 over 8 as 1 over 2 cubed, or 2 to the negative 3, and you'd get the same answer. So, express each as a single logarithm, then evaluate. Before we can use the quotient law here, because you're subtracting the logs, we have to use the power law first. And again, it works both ways. If you have the log of a power, the exponent can come in front as a coefficient. If you have a coefficient, that can go up as the power. So that's what we do for question A. I'd move the coefficients up as powers. I don't know why I put an A there for that base. It should have been 2. And 16 to the power a half. Power a half means square root. So that'll be log base 2 of the square root of 16 minus log base 2 of the cube root of 8. And the square root of 16 is 4, so it's log base 2 of 4. Take away log base 2 of 2 because the cube root of 8 is 2. If we want, we can combine these now as a single log. When you're subtracting logs with the same base, you can use the quotient law. So it'll become log base 10 of 4 divided by 2. I'm sorry, I forgot the bases there. Or log base 2 of 2, which is 1. That's asking 2 to what power is 2? The answer is 1. So again, these laws work both ways. Sometimes you're going to move the power, the exponent, in front as a coefficient. Sometimes you're going to move the coefficient up as a power. And that's what we'll do to start question B. That 2 log 5 would be the log of 5 squared, plus 2 log 2 is a log of 2 squared. 5 squared is 25. 2 squared is 4. These are common logs, no base indicated, which means base 10. We can combine these two together using the product law. It'll be the log of 25 times 4, which is 100. And again, this is a common log. This is asking 10 to what power is 100? The answer is 2. 10 squared is 100. You can check these. If I want to check B, 2 times the log of 5, close the bracket, plus 2 times the log of 2. Whoops, I forgot to close the bracket there. There we go. You get the right answer, positive 2. All right, question C. Before I can combine them, I need to get rid of the coefficients. So this 3 comes up as a coefficient. It'll be log base 5 of 2 cubed minus log base 5 of 8. 2 cubed is 8, so it'll be log base 5 of 8. Take away log base 5 of 8. The quotient law says we can combine those together into one expression by dividing the 8's. 8 divided by 8 is 1. So it's log base 5 of 1. This is asking 5 to what power equals 1? The answer is 0. Anything to the power of 0 equals 1. So we get an answer of 0 for that one, which again we could check on our calculator. In this case, the bases are not 10, so I need to use the log function to do 3 times log base 5 of 2. Take away log base 5 of 8. Try that again. Three log base 5 of 2. Take away log base 5 of 8. Basically, you're subtracting something from itself, right? If we look at this step right here, it's log base 5 of 8 subtracting log base 5 of 8. Kind of made a mess of that log there. So let me fix that. When you subtract something by itself, the answer is going to be 0, which is what we got. All right, for question D, I would use the power law to bring the coefficients up as exponents. So it'll be log base 6 of 9 squared. I'm also going to rearrange the terms to put the positive ones first and then the subtraction last. So it'll be log base 6 of 3 to the power 3, which is 27. Now you don't have to do this. I mean, you can just kind of look ahead and know that, well, I've got the first term of log base 6 of 9 squared, which is 81. If I skip a term, I'm going to have the plus log base 6 of 12. I mean, you can just skip the steps that we just wrote and just say that's log base 6 of 81 times 12. And then the last one, you're subtracting 3 log base 6, which is log base 6 of 3 cubed, or log base 6 of 27. So you'll have a 27 on the bottom. The only time I wouldn't recommend that first step is if you have a double minus. And I showed you how to deal with that. Put them together in brackets. That changes the signs inside. And then you can use the product law to simplify inside the bracket. So we might use our calculator here to figure out what 81 times 12 divided by 27 is. That's 36. This gives us log base 6 of 36, which is 2. That's asking 6 to what power is 36? So these ones like question 3, because they're all made up of variables, you're taking the log of variables, you can't really check these on the calculator like we did the other ones. You could, though, if you wanted to, by assigning a value to A, a value to B, a value to what else do we have here? D and E, no C's. Okay, so if you wanted to assign a value to each of those variables, then you can check that way. But this says express the following as a single logarithm. So we're going to use the laws. So like I did before, I would probably start by putting the positives together. And then that 1/2 log A would be log of A to the 1/2. And then I have two subtraction terms, minus 5 log E, which will be log E to the 5th, minus log of A squared. And then like we did before, I put a bracket around those last two terms, which gives me log of B plus log of D plus log of A to the 1/2 minus, and if I add these brackets, that changes all the signs inside, so it becomes log of E to the 5th plus log of A squared. So these first three are added together, so that'll be the product law. It'll be the log of B times D times A to the 1/2 minus, so I'm going to divide, and what's inside the bracket, again, they are added together, so that's the power law, or the product law again. So we can combine those 5 terms into one statement using the laws of logs. And in this case, we can simplify a bit more because we have a power of A on both the top and the bottom. So this will become the log of, we're left with B times D on top, and on the bottom we'll have E to the 5th and A to the 3/2. When you divide the A's, you subtract the exponents. 1/2 take away 2 is negative 1/2, or negative 3/2, which is what it would be if it was on top. But we know we should always write exponents or powers with positive exponents, so it moves to the bottom. Right, question B, very similar. We'll put the plus ones together. So 4 log of the 5th root of P. The 5th root of P would be P to the 1/5. And if you bring the coefficient of 4 up as an exponent, it'll be 1/5 to the power 4, which is 4/5. Again, the 5th root of P is P to the 1/5. And the 4 comes up as an exponent, so it'll be power 1/5 to the power 4. Multiply them, you'll get 4/5. Minus 3 log n is log of n cubed. Minus 2 log p, which is log of p squared. So like before, we'll put those last two terms in brackets, which will change all the signs inside. And just a quick check to make sure that what we've written is correct. Think about removing the brackets and what it'll look like. The minus sign in front of the bracket changes all the signs inside. If you remove that negative, remove the brackets there, both those terms will turn into negative, which is what we started with. But this allows us to combine those first two terms by using the product law, and the minus will be using the quotient law. But again, those two terms inside, because they're added together, we'll be once again using the product law. And like we did before, we can simplify a little bit because we have powers of p on both the top and the bottom. P to the 4/5 divided by p squared. That p squared we could write as p to the 10/5, so that there's a common denominator with the 4/5 because we have to subtract the exponents. 4/5 take away 10/5 is negative 6/5, which would be what we'd be left with. Negative 6/5. And we move it to the bottom so it becomes positive. So there's our final simplified answer. Let me fix that 6. Express as a single logarithm. Okay? So this assignment you're going to hand in for marks. It's just the one page where you write as a single logarithm first, then evaluate second. Right? You can definitely use your calculator to check after you get your answer, but make sure you write as a single logarithm first and then evaluate. You can put the original expression into your calculator to check it if you want to, but follow the instructions. Okay, so this page will be due for marks.